I am Nikki Becker, the Observing Program Leader at the National Weather Service in Gray, Maine. I'm here to talk to you about WeatherBlur, an actionable citizen science program for K through 8th graders. WeatherBlur was established in 2009, and the name comes from its blurring the lines among classroom scientific exploration and community engagement. And it not just only covers weather, it is a grant-funded program that Maine Mathematics and Science Alliance started through National Science Foundation and the National Academies of Science, Engineering, and Medicine's Golf Research Program. Currently, there are 18 K-8 schools across Maine, Mississippi, and Alabama with nearly 1,500 citizen scientists of students and educators. There are a multitude of volunteer scientists from different enterprises, to include myself. I have been with the program for the last decade. The program typically runs over a school year. Maine Mathematics and Science Alliance designed WeatherBlur to be a place-based citizen science program that meets next-generation science standards and Common Core math standards. It also includes computational thinking, which was popularized by a Carnegie Mellon professor, Dr. Wing, in an article in 2006, and is defined as the thought process involved in formulating problems and their solutions so that the solutions are represented in a form that can be effectively carried out by an information processing agent, such as a human or machine, or even both. The project timeline, this is an example, begins before the school year starts, as the Maine Mathematics and Science Alliance has a summer institute for the educators and the scientists. It's mainly geared towards the newer ones where it's their first year or second year to help with them, but all educators are invited to come. And then they also bring out any new things or changes. And then at the beginning of the school year, they start to connect the schools through the online platform, making sure all the proper paperwork is filed with everything that needs to be done. And then they start the WeatherBlur 4-stage process, which then goes pretty much from the fall through early spring through the school year. Because this program involves an online platform and connecting students across one state, let alone multiple states, it was able to function even when COVID hit in 2020, and has been allowed to continue even to this day. And some of that flexibility and the things that some of the skills some of those educators learned actually helped them with their students when the pandemic did hit. So that was something that was helpful that came out of it unexpectedly. The WeatherBlur is set up into 4 different processes through the stages of the program. They are the I wonder, investigate, explore data, and act. So now I'm going to go over each of these processes a little bit to give you an idea of how the program works. The I wonder process is the first stage. It gives students an opportunity to go outside and make observations of the natural world around them. And then they use these observations to create posts of I wonder questions, of things that make them curious, the basis of all science exploration. That starts the discussion with other students and teachers and scientists across the WeatherBlur platform. And towards the end of the process, after a couple months, they start to work towards with the WeatherBlur community towards a SMART question. SMART question needs to be specific, measurable, attainable, relevant, and timely. This is very similar to a hypothesis. This allows the students to be able to have something to investigate. The topics have been a variety of different things over the years, from the changing of weather conditions outside their school, to counting birds, to king tides, such as the example here, to studying microplastics, and even air quality. The second process is to investigate. This is where the students investigate their smart questions and they become the researcher. Students, with the guidance of the teachers and scientists, create data collection protocols and then collect the data. The third step is where the students get to explore the data they collected. And they'll be analyzing by creating graphs, whether they be handmade or using a program called Tuva that all of the schools have access to through the WeatherBlur program. And this allows them to draw conclusions from their SMART question, whether they're seeing patterns and relationships in the natural world. The direct answer to their SMART question may be very easily found. The final stage in the WeatherBlur process is ACT. It's basically where the students communicate their findings within the WeatherBlur community and their local community. And the students are also able to develop action plans based on their findings. And just share the photographs and videos and files within the WeatherBlur community also. Now, when they create action plans, these can vary, but usually it's something that they can act upon from the investigation that they did. So, for example, last year a school did an investigation on bird counts, and their action plan was to make bird feeders for the nursing home in their community. So it was very interesting to see how the students go from one thing to the another. As a volunteer scientist in the WeatherBlur community, I'm able to interact with the students to provide scientific guidance and my expertise in meteorology. And also, over the years, I have learned a lot from being a member of this community, from the students myself, and I truly enjoy seeing and giving them a perspective into a scientific world that may seem a mystery to many. I'd like to acknowledge not only the grant funders, but also Maine Mathematics and Science Alliance, along with many multiple of other partners that have helped make this program a success over the years, and I look forward to continue working in it. Thank you for taking the time to listen to my presentation about WeatherBlur, and please let me know if you have any questions. Thank you.